All right, today we're going to look at math a little differently. Not as just a bunch of problems you have to solve, but as a language. A really powerful one that, believe it or not, you can learn to speak. So, let's dive in.
You know that feeling, right? Where you're staring at an equation packed with all these strange symbols, and you just feel totally lost, like you're trying to read a language you've never even seen before. Well, that feeling is actually the perfect place for us to start.
Because what if that feeling is spot on? What if math really is a language? One that has its own vocabulary, its own set of grammar rules, and its own way of expressing some incredibly big ideas. Today, we're going to learn the basics of how to speak it.
So if it's a language, what kind are we talking about here? It's definitely not like English or Spanish. No, this is a language that's built on pure logic, designed to be understood by anyone, anywhere, maybe even anywhere in the universe.
On one hand, it's got all the stuff you'd expect. It has vocabulary, words, and symbols. It has grammar, rules for how to put them together. But here's what makes it so different. It's built for absolute precision, which gets rid of all the confusion you can get in everyday conversation. Its symbols mean the exact same thing, whether you're in Tokyo or Toronto.
And these characteristics make it a real powerhouse. It's precise, meaning a statement can only be read one way. It's concise, so you can pack huge ideas into just a few symbols. It's powerful enough to describe the very fabric of our universe, and it's universal, which means it breaks down every single cultural and language barrier.
Okay, so if we're going to learn to speak math, we've got to start where every language class begins, with the vocabulary. We have to learn the words.
Now, the funny thing is, the most common words in math aren't really words at all. They're symbols, and you already know most of them. You've got your operation symbols like plus and minus that tell you what to do. And you've got your relationship symbols, like the equal sign or the greater than sign, that tell you how two things are connected. These are kind of like the verbs and the conjunctions of math.
But then you get to the really cool stuff, these advanced logic words. These symbols let you build these airtight arguments and express really complex thoughts super efficiently. That upside-down A literally means for all, and those three little dots mean therefore. Learning these is like graduating from basic phrases to writing poetry.
Okay, we've got our words. But just like in English, you can't just throw vocabulary together randomly and hope it makes sense. You need grammar. And in math, grammar is all about following the right structure and rules.
Before we hit the rules, let's get clear on what a mathematical expression is. The best way to think of it is as a phrase, not a full sentence. It's a bunch of symbols that stand for one single idea or value. It isn't making a claim, it just is. You know, like saying the big red ball, not the ball is big and red.
And that brings us to the most important grammar rule of all, the order of operations. You probably remember it as PEMDAS. This rule is absolutely non-negotiable. It makes sure that every single person reads a mathematical phrase the exact same way, so we all get the same meaning. It's the key to making this a universal language.
So, let's put this grammar to the test, shall we? Here's a mathematical phrase. We're told that our variable x is equal to 1. Our job is to use the rules of PEMDAS to figure out the one single value this whole thing represents.
Okay, following PEMDAS, P comes first, so we start with parentheses. We substitute 1 for x, and 1 plus 2, well, that gives us 3. Look at that, the phrase is already getting simpler.
Next up is e for exponents. So 3 squared becomes 9, and our phrase simplifies just a little bit more.
And now for the final steps. We multiply 3 by 9 to get 27, and then we subtract 5, which leaves us with 22. See that? By following the grammar, we read the phrase correctly, and we found its single, unmistakable meaning.
All right, now that we have some vocabulary and grammar under our belts, let's see the real magic of this language, translation. This is where we can take a kind of clunky idea in English and turn it into something short, elegant, and powerful.
Take a look at this sentence. It's a full thought, and it's clear enough in English, right? But it's also a little wordy. It takes a while to say. So how would we say this in the language of math?
And there it is. Boom, all of that meaning, the entire idea packed into 5 simple symbols. A number is just x, the sum of, and 5 is just plus 5, and is greater than 10 is greater than 10. This is that beautiful conciseness we were talking about.
So, who actually speaks this language, and where is it even used? Well, as you can probably guess, the answer is pretty much everywhere, for almost everything that matters.
It's the native language of science. It's how we write the fundamental laws of physics. It's the language of technology, the bedrock for every computer program you use, for all the encryption that keeps us safe. And yeah, we all speak it in our daily lives, every time we make a budget, check the weather, or just try to make sense of the news.
And you know, this is not a new idea. Hundreds of years ago, the great astronomer Galileo Galilei put it just perfectly. He saw the universe not as some big, chaotic mystery, but as a book written in the language of mathematics, just waiting for us to learn how to read it.
So if there's one thing to take away from all this, it's this. Math isn't just some subject to get through in school. It is a language built for precision, for power, and for universal understanding. And just like any other language, it's a tool that anyone, and I mean anyone, can learn to use.
So the question I really want to leave you with is this one. Now that you know the basics, the vocabulary, the grammar, what conversations do you want to have? What ideas will you build? And what will you choose to say with this incredible language?